Hey guys, welcome to the new video. And in this video, I'm going to see my timetable to you because I'm preparing for the GATE 2026, and actually, like approximately 170 approx once from today. Actually, exactly 169 days are remaining for the GATE 2026, and today we are revising engineering mathematics, and the chapter is called linear algebra, and it's a important chapter. And you know that the all maths are important because maths actually have high weightage. You know that, or you all know that maths having weightage approximately, not approximately, exactly 13 marks. Okay, aptitude having 15 marks. So in this session we are going to revise linear algebra, and hope we will, if the time allow, we will definitely do some PYQ on the linear algebra. And I was making this video so that I can study continuously, because from previous 2 to 3 days actually I'm getting distracted more, because I don't know why it's going on, but last time I was just studying, and I just skip all, and I start scrolling, and I was continuously scrolling last night. So that's why I decided to make this video, because I'm recording this. So definitely I will going to see after this video. I'm going to see this video after recording this video. So definitely I will say that I have done something today. Okay, so let us start the revision. And actually I have revised 2 3 papers. Like, I have complete determinate, I have complete matrix, and now we are going to understand what is the properties of the adjoint. And you know all about the adjoint. Why we find the adjoint? Generally we find the adjoint to find the inverse. Okay, because you know the formula of the inverse is nothing but the adjoint of any matrix divided by the determinant of that matrix. Okay, so what are the properties of the adjoint? So properties of the adjoint, let us say, if any matrix A which having order n cross n, then we can say that A into adjoint of A is equals to, or we can say adjoint of A into A will be equals to determinant of A. It means the determinant value of the A into identity matrix of the order n cross n. It's same as the order matrix A. Okay, and the second property of this adjoint is, if there is a square matrix of A which is having order n cross n, then we can say that if we want to find out the determinant of adjoint of adjoint of adjoint of r times of adjoint of A. This question, when I look this question, the PYQ actually got confused, but I see the short trick of this question to do. So that's, it's very simple. It's very simple. First you have to find out the determinant of the A, and then you put the power n minus 1 raised to the power r. Okay, simply the determinant, first you have to find out the determinant of A raised to the power n minus 1 raised to the power r, simply, where r is nothing but the how many you are finding, how many times you are taking adjoint. R is nothing but the how many times you are taking adjoint, and n is nothing but the order of n cross n, order of matrix A. Okay, and remember, I think the concept of the adjoint will be uh, only valid for the square matrix. Okay, example, there's a lot of example, not lot of, there's one example here. Okay, yeah, definitely, and there is some property here. If you find out the trace of the adjoint of A, if you find out the trace of the adjoint of A, it means there is a matrix of adjoint of A, and you have to find out the trace of that matrix. Then what you have to do, that you just simply sum of the diagonal elements. Trace and the sum of the diagonal elements. So we can we can add the determinant of A n times. Okay, okay. Definitely add the determinant of a n times, then we can directly write it n into mod of a, n into mod of a. Definitely, if you want to find out the trace of adjoint of a, then you can directly write like that, n is nothing but the order of matrix times of determinant of that matrix. That is okay. And you know that a into adjoint of a, if you want to find out the determinant value of the a into adjoint of a, okay, if you want to find out the value of determinant of a into adjoint of a, then you have to do that product of the diagonal elements. And you know that, and when you will see that product of the diagonal elements, what's going on here, a into adjoint of a can be written as mod of a into identity matrix of n cross n, and when we will write that, then we can find out the trace. So trace will be simply n times of mod of a. Yeah, definitely n times of mod of a, and adjoint of a, and the determinant of a into adjoint of a will be product of the diagonal elements. Yeah, determinant is nothing but the product of the diagonal elements, na. So determinant a raised to the power n, that's it. I hope you didn't understand anything, sorry for that, but okay. From here we are going to start the rank. What is rank of the matrix? So rank is nothing but the, what is the rank? What is the actually meaning of the rank of any matrix? So rank is the order of non-singular submatrix of the highest order that can be exist in a given matrix. If you want to find out the rank of any matrix, then you have to see that, then you have to take the non-singular submatrix of the highest order, that's it, and the order of that matrix will be the rank. You have to just find out the highest order non-singular submatrix. Okay, you have to just find out the highest order non-singular submatrix that can be exist in a given matrix, and the rank will be nothing but the square, not the square, rank will be nothing but the order of that matrix which you have found out, which having highest order, and which must be, it should be non-singular. Okay, that's the necessary condition, you can say. And we know, okay, so we know about the rank, and let's start. What is the properties of the rank? Properties of the rank: while calculating the rank, we are free to apply all three elementary operations. Yeah, if you are calculating the rank of any matrix, then we are free to apply all three elementary operations, all three elementary operations, either it may be row operations or maybe column operation. Okay, equivalent matrix. Okay, what is the equivalent matrix? The matrix obtained by applying finite numbers of the elementary operations are called the equivalent matrix, and equivalent matrix has the same rank as the first matrix has. Let us assume there is a matrix A, and the rank of the matrix A is 3. Let us take an example. Okay, and we have make a equivalent matrix of the A. It means we put the 2 to 3 elementary operations in the matrix A, and we get the equivalent matrix of the A. Then we can say that the equivalent matrix of the A and rank of the equivalent matrix will be equal to the rank of A. Okay, this is the properties of the rank. This is the property of the rank. Okay, so I think video have been gone up to that 8 minutes, approximately 9 minutes. Okay, so let's end, because I wanted to tell you something. I am from actually Hindi medium. So I am making this video to improve my English. Sorry guys to waste your time. I'm just trying to improve my English from my study, and that's it. Bye bye.